Okay, hello grade 4s. In grade 4, you're going to learn about equivalent fractions. And equivalent fractions are fractions that they're different fractions, or they're different numbers, but they represent the same fraction, if that makes sense. So they're different numbers, but they represent the same fraction. For example, if I had a pizza, I'm going to go back to pizzas because pizzas are great for teaching fractions, and all my pizzas are going to be rectangular just because they're easier to draw. So in my pizza, I have 4 slices. I cut it into 4 equal pieces. And remember what I taught you in the other video, the review of grade 3, the bottom number, or the denominator, and you need to know that in grade 4, the denominator, or the bottom number, is the total number of equal parts or slices in my pizza. And the total number of equal slices is 4. I have 1, 2, 3, 4. If I ate if I ate 2 of those slices, I'm referring to these 2 equal slices that I ate, so I'm going to put the number 2 on top. Now, if I asked you what fraction of the pizza did I not eat, now I'm referring to these 2 slices, the fraction would stay the same. It would be 2 quarters. Okay, so I ate 2 quarters of the pizza, and I did not eat 2 quarters of the pizza. Or we could look at this great big chunk of the pizza. This is half the pizza, because if I look at this pizza, half the pizza was eaten and half was not. So 2 quarters is the same thing as saying, hey, I ate half the pizza, because I ate 2 quarters and there's 2 quarters remaining. So I ate half. Okay? So these fractions are called equivalent fractions. Okay, and in grade 4, you need to understand what equivalent fractions are. I challenge you to say that fast, really quick. Say it fast 5 times. Equivalent, equivalent, equivalent. It's a tricky word to say. Equivalent fractions. Okay, let's do another example. Do a bigger pizza this time. And in this pizza, I cut this pizza into 6 equal slices. Okay, so again, my fraction, the total number of equal slices in my pizza is 6. That's the total number of slices. 1, 2, 3, 4, 5, 6. 6 slices altogether. If I ate in my lovely pizza, if I ate, let's go even, yeah. Ooh, I don't know whether to do that or not. Let's do it this way instead. I'm going to take away this one. I want to make this one a little harder than half. I don't want to do half again. So I didn't eat this slice over here. Okay, so in my example, if I asked you what fraction of this pizza did I eat, I ate 2 slices. So I ate 2/6 of the pizza. 2/6. Or another way of saying that is I ate, if I have 6 pieces all together, and if I ate 2, I would have to sit down 3 times to eat that whole pizza. I would eat 2 today, 2 tomorrow, and 2 the next day. So if I ate 2 each day, and if I asked you, okay, if I ate 2 slices every day, what fraction of the pizza would I eat in one day? It would be like cutting my pizza into thirds, or 3 sections. there would be this section, there would be this section, and there would be this section. Okay, they're all going to be equal. So if I were to break my pizza down into 3 sections, or 3 bigger pieces, really what's happening is, if I said I'm going to eat 2 slices a day, or I could also say I'm going to eat 3 really big slices of this pizza every day. In other words, I'm going to eat 1/3 of the pizza every day. Okay, so I'm talking about the same thing. These fractions look different, but they actually are equal. They're equal, they actually mean the same. Okay, does that make sense? So if I said I'm going to eat 2/6 of the pizza, 2 slices out of 6, or I'm going to eat 3 bigger slices each day, or 1/3 of the pizza, because now I'm talking about 3 parts and I ate 1 big piece. Let's try it again. It's a little tricky to understand. Let's do a long rectangular pizza this time because it might be easier to see it. And on this pizza, I'm going to have 1, 2, 3, 4, 5, 6. Okay, we're going to pretend all these slices are equal. So the total number of slices, equal slices, 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to eat 2 slices a day. So on the first day, if you ask me, Mr. Lott, what fraction of that pizza did you eat today? Well, I have 8 slices in total, and I ate 2 of them. So I ate, get it, 8s? I ate 2/8 of the pizza. Okay, and I have 6/8 left over, but I ate 2/8 of the pizza. And then someone said to me, well, if you ate 2 slices every day, right? So again, going back to my other example, so I'm going to now make these slices bigger. So this is day 1, I'm going to eat 2 slices. Day 2, I'm going to eat 2 slices. Day 3, I'm going to eat 2 slices. And day 4, I'm going to eat 2 slices. So now I'm thinking, instead of 2 slices I'm eating, I'm going to pretend I didn't cut them in half, and I actually ate, this is 1 big whole slice now. So if they said to me, if I ate 2 slices a day, I'm going to pretend they're 1. What fraction did I really eat here? Because I would eat 2 every day, right? Which is going to be 8 slices. But now I actually ate 1/4 of the pizza, because now I have this section, this section, this section of the pizza, and this section of the pizza. So I ate 1/4 actually of that whole pizza. Okay, so these, even though the fractions look different, they're equal. They mean the same thing. And we call these kinds of fractions equivalent fractions, that these fractions actually are the same, even though they're different. Okay, let's do one more. I'm going to challenge you to answer this one on your own. I'm going to go back to circles. Okay. So in this example, if I asked you, what fraction of these circles is red? So the bottom number is the total number of circles that I have, which is 4, and I colored 2 in. So 2/4 of these circles are red. Or a half of the circles are red. That's an easier way of saying it. So if I asked you what fraction of these circles are red, there's 2 answers you could give me. You could raise your hand and say 2/4 of those circles are red. But then someone else next to you could raise their hand and say, 1/2 of those circles are red. And I would say you are both correct because they mean the same thing. Just different ways of saying it.